Hi everyone. This is part 2 in our series on trigonometry where we are calculating unknown side lengths. In the last video, we applied sine, cos, and tan to situations where we had one side length and one angle, and we saw that was enough information to figure out another side length. Today we're going to do exactly the same thing, except we just have to add one more step of algebra because the equation that we start with is a little bit more challenging. So, by now you've seen sine, cos, and tan many times. And remember, SOHCAHTOA is a very easy way to remember the definitions for sine, cosine, and tangent. I really do think that you should memorize this. At least memorize SOHCAHTOA, and then you can reproduce the other definitions for sine, cos, and tan. Let's get straight into an example. So our goal is to find the unknown side length, x, and we will round to 2 decimal places as we did in the last video. So here's our angle, 70 degrees. And remember, our first step in any trigonometry problem is to label the sides of our right-angled triangle. Now, in this case, we were given O and H, and the trig ratio with O and H is sine. So I'm going to say sine of 70 degrees equals the opposite divided by the hypotenuse. I can now replace O and H with the numbers that were given in the question. Sine of 70 equals 20 divided by x. And one thing I want you to notice here is x is at the bottom of the fraction now. We didn't have this in the last video. So we're going to need to use a slightly different approach to solve this equation for x. It might not be obvious if you're seeing this for the first time. Remember, if I do something to one side of the equation, I need to do the same thing to the other side as well. In this equation, I have divided by x. The opposite of dividing by x is to multiply by x. So I can say x times sine 70 degrees equals 20. And we don't usually write the times symbol. You'll actually see that x and times look very similar. So to avoid any potential confusion, I'm just going to write x sine 70. And I'll write a note here that this means x times, or that is multiplication, sine 70. Now, I just want to get x by itself. I don't have x yet. I have x multiplied by another number. In this case, that number is sine 70. So what I can do is divide both sides by that number. So now I'm going to divide both sides by sine 70. And that's going to move sine 70 to the bottom of this fraction. So on the right here, I'm going to write the steps that we've done. So here, we multiply both sides by x. And here, we divide both sides by sine of 70 degrees. And you'll notice we're actually done now because we have x equals some number. I'm now at a stage where I can type something into the calculator and it's going to give me an answer. So grab your calculator out. We're going to find 20 divided by sine 70. So I get 21.28356, and that goes on forever. And if I round this to 2 decimal places, I get 21.28. And we're done. So the first step was the same. Second step was the same. But you can see that because we had x in the denominator, the algebra involved in rearranging this whole equation for x was a bit complicated. One thing you might notice is that the x and the sine 70 swapped places. So if you don't want to go through all that pain, you could remember that if I have x in the denominator and a trig ratio out the front, I can just swap them. So I'll leave that colored in the notes so that you can see that. And I'll write a note up here in a different color. So I'll say, notice that x and sine 70 get swapped. All right, we'll do 2 more examples, and the approach is going to be exactly the same. So here's a new problem. This time I've got an angle, 40 degrees, and I should start by labeling the sides of my triangle. So O, A, and H. I need a trig ratio, in this case, where I have H and A, because I don't have O. The trig ratio of A and H is cosine, so I should use cos as my starting point. Cos of 40 equals A divided by H, and I can replace those numbers with what was given in the question. So A is 25 and H is X. I can multiply both sides by X to get X cos 40 equals 25, and then I can divide both sides by cos 40 to get X equals 25 divided by cos 40. And again, notice cos 40 and X got swapped with X. Well, they swapped positions, I should say. If you don't want to do the algebra, I'm happy for you to go from this step directly to this step in one go. And now we just need to get our calculator out. So we need to evaluate 25 divided by cosine of 40. And this time we get the number 32.6352 to 4 decimal places. And if I round this to 2 decimal places, I'm going to get 32.64 because the third digit is 5 or larger. Whereas before, the digit was smaller than 5, and so I rounded down. Okay, one more, and then we're done. So here's our angle, 32 degrees, and I've been given the adjacent side and the opposite side. I have not been given the hypotenuse. So if I'm using SOHCAHTOA, I'm noticing that I need to use a trig ratio with O and A in it. And that trig ratio is tan. So I will start by writing tan of 32 equals the opposite over the adjacent, which means tan of 32 is 12 divided by x. This time I'm just going to do the swapping method. So I can go straight to writing x equals 12 divided by tan of 32. So we're swapping here. And now I use the calculator. So 12 divided by tan of 32 gives me 19.2040. And if I round this to 2 decimal places, I look at the third digit, which is 4. This is smaller than 5, so I'm going to round my answer down to 19.20 rather than rounding up to 19.21. Okay, so that is all we need to know to use trigonometry to find unknown side lengths when we know one side and one angle. That is enough information to work out the other sides. In the next video, we're going to do something a bit different. Next time, we're going to go from having 2 sides to finding an angle. See you then.